Hello again. This is some commentary and solutions on challenge problems B and C offered on 9/29/2023. One of those problems was to find the unique self-counting digit frequency string for base 10. That is, we seek a 10-digit number whose first digit counts how many zeros are in the number, the second digit counts how many ones are in the number, and so on, up to the 10th digit counts how many nines are in the number. And this was offered to illustrate a guess and check approach. I'm happy to report that one of our members solved this in about 2 minutes, but then spent the next 10 minutes explaining how they solved it. And so it was a very useful thing. The answer is 621,000,1000. Although this is not offered as an explicit challenge problem, some things that could be thought about are: what other number bases other than 10 do such strings exist? When are they unique? And so on. So there's always more things to think about. The handshake problem was not solved correctly, or at least no solution was presented, so we go over that now. So Mr. and Mrs. Adams recently attended a party at which there were 3 other couples. Various handshakes took place. No one shook hands with his or her own spouse, no one shook hands with the same person twice, and of course no one shook his or her own hand. After all the handshaking was finished, Mr. Adams asked each person, including his wife, how many hands he or she had shaken. To his surprise, each gave a different answer. How many hands did Mrs. Adams shake? And this features making a diagram and a process of elimination. And so let's start with thinking about the party people. There were 4 couples, and so we're labeling them A through H for now, although we are going to renumber them as we go forward. Since each of the 7 folks asked gave a different answer, the responses that Mr. Adams received were 0, 1, 2, 3, 4, 5, 6. So one person shook hands with 6 other people, and let's just call them A. So A shook hands with 6 other people. The person who shook hands with 0 people is called H, and you can conclude that H must be married to A. So A and H are a couple, and we've already assigned 6 and 0. So 6 and 0 are covered. Now we move on to 5, and relabeling as needed, we can consider B as the person who shook hands with 5 people, and moreover that those 5 were A, C, D, E, and F. Therefore, the one who shook hands with only one other person in the group had to be G. And moreover, this tells us that B and G are a couple. So now we have A and H are a couple, B and G are a couple, and so we also have assigned 0, 6, 5, and 1. Now we're down to the 4 handshake individual. Now relabeling as necessary the points C, D, and E, we call this individual C. And now we have this as our diagram. And from this, we can conclude that C and F are married. So we have concluded that A and H are a couple, B and G are a couple, C and F are a couple, and now we've assigned 0, 1, 6, 5, and 4 are assigned. There's only one remaining pairing of the couples, and that means that D and E are a couple. And both of these are showing 3 handshakes. Now, since only one 3 was reported, one of these was Mr. Adams, and he did not report to himself, but the other one had to be his wife. So the answer is 3. These problems were not totally made up. They were drawn from these resources. In closing, remember, time is precious. Each day must count. Do the math. It will make you strong. Take care and God bless you all.